Good afternoon, everyone. So today we're going to discuss the week 7 or the software development method. Okay, so before that, these are the learning objectives. All right. So number 1, understand the concept of software process and software process models. Number 2, have been introduced to 3 generic software process models and when they might be used. Number 3, know about the fundamental process activities of software requirements engineering, software development, testing, and evolution. Number 4, understand why processes should be organized to cope with changes in the software requirements and design. And number 5, understand how the rational unified process integrates good software engineering practice to create adaptable software process. Okay, so before we define what is methodology, okay, so let's talk about with the software development, or we call it the software process. Okay, what is software process? Okay, so software process is a set of related activities that leads to the production of software product, right? So these activities may involve the development of software from scratch in a standard programming language like Java, C, C++. However, business applications are not necessarily developed in this case. New business software is now often developed by extending and modifying existing systems or by configuring the integrating of the shelf software or system components. Okay, so there are many different processes, but almost include the 4 activities that are fundamental to the software engineering. So what are those activities? So number 1, software specification. Number 2, software design and implementation. Number 3, software validation. And number 4, software evolution. Now, let's talk about with the software specification. Okay, so before we go into discuss the methodology, let's talk about the software specification. So software specification, the functionality of the software constraint on its operation must be defined. And this stage of development, okay, so you're going to specify the use or the components that you're going to apply in your system. Okay? Another thing is the software design and implementation. Okay? So software design and implementation, this is the stages that the software to meet the specification that you must be produced. In short, it's what the process or what did you specify during the first stage or the software specification. You're going to apply it or you're going to use it during your design and implementation. Okay? Number 3, software validation. The software validation, the software must be validated to ensure that it does what the customers want. Okay, so you need to validate it. You need to assess it first, or what we call it, test it. If the software is meet the requirements of the client. And number 4, which is the software evolution, the software must be what? Evolve. Okay? It must be evolving or nag-i-evolve siya to meet changing customers' needs. Okay? Since we're dynamic changing, our modern area is a dynamic changing. So we expect the evolution. We expect that we change, we upgrade our software that we're going to develop. It needs to be evolved or it needs to be upgraded. In some form, these activities are the part of the software process. Okay, so in practice of the course, there are complex activities in themselves, include the sub-activities such as requirements validation, architectural design, unit testing, and etc. So there are also supporting process activities such as documentation and software configuration management. When we describe and discuss processes, we usually talk about the activities, and these processes such as specifying a data model, designing user interface, etc., and the ordering of these activities. Okay? However, as well as activities process description may also include number 1, products, which are the outcome of the process's activity. For example, the outcome of the activity of architectural design may be a model of the software architecture. And number 2, the roles, which reflect the responsibilities of the people involved in the process. So example of the roles are project manager, configuration manager, and the programmer. Number three, pre and post condition, which are the statements that are true before and after a process activity has been enacted or the product produced. For example, before the architectural design begins, a precondition may be that all the requirements have been approved by the customers. After this activity is finished, a post condition must be or might be that UML models, okay, describing the architecture have been reviewed. Okay? So, software processes are complex and like all intellectual creative processes, rely on people making decision and judgment. So there is no ideal process and most organizations have been developed their own software development process. Processes have been evolved to take advantage of the capabilities of the people in an organization and the specific characteristics of the systems that are being developed. Okay? So now, let's talk about with the methodologies. Okay? So we call it the software models, the software process models. Okay? So methodologies, this is what? Development methodologies add structure to the development. Okay? Development process. Okay? We apply methodology because we want it helps you to make a smooth development process. It helps your development smooth. Okay? So methodologies is a simplified representation of the software process actually. Each process or each model represents a process from a particular perspective and thus provides only partial information about that process. Okay? For example, a process activity model shows the activities in their sequence but may not show the rules of the people involved in these activities. So in this topic or in this section, I will introduce a number of very general process models. Okay, so sometimes we call it process paradigms. In present this from architectural perspective. Right? So that is we see the framework of the process but not the details of specific activities. So these generic models are not definitive description of the software process. Rather, they are abstraction of the process that can be used to explain different approaches to the software development. You can think of them as a process framework that may be extended and adapted to create more specific software engineering process. Okay, so these are the models, okay, the software process models or methodologies that we're going to discuss here. So the Waterfall Model, the Incremental Development Model, and reuse-oriented software engineering, as well as the spiral and the rod model. Okay, now let's talk about with the waterfall. So waterfall, this takes the fundamental process activities of a specification development, validation, and evolution and represents them as a separate process, such as requirements, specification, software design, and implementation design, and so on. Okay, so the waterfall model, the first published model of the software development process. Okay, so actually this is the first model that we use, early 90s. Okay, so was derived from the more general system engineering process by Royce 1970. So this model is illustrated, okay, because of a cascade from one phase to another. Okay, as you can see, this is cascading or cascade from one phase to another phase. And this model is known as the waterfall model or software life cycle. So the waterfall model is an example of plan-driven process. Okay, in principle, you must plan and schedule all the process activities before starting work on them. Okay, so the principal stages of the waterfall model directly reflect to the fundamental development activities. So we have the requirements. So requirements, analysis, and then definition. So the system, services constraints, and goals are established by consultation with system users. So of course, you need to connect. You need to know the information, the data that you're going to apply to your system. So which is the user or your company. Okay, they are then defined in the detail and serve as system specification. Okay, another thing is the system and software design. Okay, so the system design or the software design process allocates the systems to either hardware or software system by establishing an overall system architecture. Okay, so software design involves identifying and describing the fundamental software system abstraction and relationship. Okay, so another thing is the implementation. So during this stage, the software design is realized a set of programs or program units. So unit testing involves verifying that each unit meets its specification. Okay, and of course the integration and the system testing. So the individual program units of what we call this of the integrated and tested as complete system to ensure that the software requires requirements have been met. And after the testing, the software system delivered to the customers. Okay, and lastly, the maintenance or the operation and maintenance. Normally, okay, although not necessary, this is the longest life cycle phase. So the system is installed and put in practical use. Maintenance involves correcting errors which were not discovered in earlier stage of life cycle, improving the implementation of system units, and enhancing the system service as new requirements discovered. Okay, so in the principle, the result of each phase is one or more documents that approve or sign off. Okay, the following phase should not start until the previous phase has finished. So these are the disadvantages of the waterfall. So if you encounter an error during the stages or the phase of the development, okay, you need to finish first the stage before you can proceed, or you're going back to the stages which is there's an error. Okay, so you need to finish the last part, which is the maintenance. Okay, so in practice, this stage overlap and feed information to each other. So during design, problem with requirements are identified. So during coding, design problems are found, and so on. Okay, so the software process is not simple linear model but involves feedback from one phases to another. So document produced in each phase may be then have to modify, reflect the changes made. Okay, so because of the cost of the producing and approving documents, iteration and can be costly involved in significant rework. Therefore, after a small number of iteration, it is normal to freeze part of the development, such as the specification, to continue with the later development stages. Okay, so problems are left for later resolution, ignore or program around. So this premature freezing or requirements may mean that the system would do what the user wants. Okay, it may also lead to badly structured system as design problems are circumvented by implementation tricks. Okay, so during the final life cycle or the operation and maintenance, the software is put into use. Okay, errors and omissions in the original software requirements are discovered. Program and design errors emerge and need for the new functionality is identified. So the system must therefore evolve to remain useful. Making these changes, software maintenance may involve repeating previous process and stages. Okay? Alright. Ayan. So, with the waterfall issues, so real projects often break out with the linear progress of these models. So, the design changes to implementation problems. If multiple developers are not tightly coupled, the confusion can result and change in previous phases can be invalid considerable in the previous work. Okay? So what happens when the customer does not specify the requirements completely? Can the customer know all the requirements prior? The requirements may change as the customer's needs change. The requirements may change once the customer sees the end result. Okay? So, of course, the changes or the, what we call this, the additional or the involvement of the system is in the last part. Okay? So, you need to specify the requirements or you need to fix the stages of development to finish your system. Okay? So, customer patient and forethought is required. Okay? Since the waterfall issues or the waterfall development is, you need to finish first the development until the end or the maintenance part. Okay? So, the customers must wait for the final output. Especially because of you need to go back to identify those errors. To check those errors. Okay, so now let's talk about with the increment development. Okay, so incremental model or incremental development. Okay, the increment model is iteratively applying the waterfall model. Ayan. So each increment is a partial product, not a prototype. increment progress in parallel with the product delivery of one increment feeding into design phase of the next. Okay, so this is the increment. Okay, so incremental development is based on the idea of developing an initial implementation, exposing this to user comment and evolving it through several versions until an adequate system has been developed. Right? So specification development and validation activities are interleaved rather than separate with rapid feedback across activities. Okay? Another thing, incremental software development, which is a fundamental part of the agile approach. It's better than waterfall approach for most business e-commerce and personal system. Incremental development reflects the way that we solve problems. Okay, so we really work out to complete a problem solution in advance, but move towards a solution in series of steps, backtracking when we realize that we have made a mistake. By developing the software incremental, it is cheaper and easier to make changes in software as it's being developed. Okay, so compared to waterfall. So each increment or version of the system incorporates some of the functional that is needed by the customers. So generally, the early increments of this system include the most important or most, what we call this, most urgently required functionality. Okay, so this means that the customer can evaluate the system at really relatively early stage in the development to see if it delivers what is required or what it needs in the company or the client. If not, then only the current increment has to be changed and possibly new function defined for the later increments. So incremental development has three important benefits. Okay. Alright. So compared to waterfall model, so number one, the cost of the accommodating changing customer requirements is reduced. So the amount of analysis and documentation that has to be done is much less than is required within the waterfall model. Okay, so this is the advantage. Number two, it is easier to get customer feedback on the development work than has been done. And customers can comment on the demonstration of the software and see how much has been implemented. Okay, and customers find it difficult to judge progress from the software design and documents. Okay, so another benefits of the incremental development. Okay, so more rapid delivery and deployment of useful software to the customers is possible, even if all the functionality has not been included. So customers are able to gain value from the software earlier than is possible with a waterfall process. Okay, incremental development in some form is now the most common approach for the development of application system. This approach can be either plan-driven, agile, or more usually a mixture of these approaches. In a plan-driven approach, the system increments are identified in advance. If an agile approach is adopted, the system or the early increments are identified, but the development of later increments depend on the progress and the customers. Okay? Ayan. So, from a management perspective, the incremental approach has two problems. Okay, so number one, the process is not feasible. Managers need regular deliverables to measure the progress. Okay, so if systems are developed quickly, it is not cost-effective to produce documents that reflect every version of systems. Okay, so number two, system structure tends to degrade as new increments are added. Unless time and money is spent on refactoring to improve the software, regular change tends to corrupt its structure. Incorporating further software changes becomes increasingly difficult and costly. Okay? So the problems of the incremental development become particularly acute for large complex. Okay? Where different teams develop different parts of that system. The large systems need a stable framework or architecture, and the responsibilities of the different teams working on the parts of systems need to be clearly defined with respect to that architecture. Okay? Alright, so another thing is the reuse-oriented software engineering. Ayan, so actually wala siya dito eh. But, sige. So reuse-oriented software engineering, in the majority of software projects, these are some of software reuse. Okay? So this often it happens informally when people working on the project know of design codes are similar to what is required. So they look for this modify modify them as needed, and incorporate them into the other system. This informal reuse takes the place irrespective of the development process that is used. Okay? However, in the 21st century, software development process that focus on the reuse of existing software have been become widely used. Okay? So the use-oriented approach really on the large based on reusable software components and integrating framework for the completion of these components. Sometimes these components are system in their own right. Okay? So in general, general process model for reuse-based development. Okay? So although the initial requirements specify stage and the validation stage are comparable with other process, the intermediate stage in the use-oriented process are different. Okay, so these are the difference. These are the stages. So component analysis, requirements modification, system design with reuse, and development and integration. Now, let's talk about the component analysis. Okay, in this stage, given the requirement specification, a search is made for components to implement that specification. Usually, there is no exact match, and the components that may be used only provide some the functional required. Okay, so this is more on about the components. This is about the search for the components that needs to implement to the system with the reuse-based development. Okay, another thing is requirement modification. So during this stage, the requirements are analyzed using information about the components that have been discovered. So they are then modified reflects the available components where modification is impossible. So the component analysis activity may be entered to search an alternative solution. Okay? So another thing is system design with reuse. During this phase, the framework of the system is designed or an existing framework is reused. Okay? The designer takes into account the components that are reused and organize the framework. Okay? To cater for this, some new software may be or may have to be designed if reusable components are not available. And lastly, or the last stage is the development and integration. Okay? Software that cannot be externally procured is developed, and the components and cost systems are integrated to create the new system. Okay? So system integration in this model may be part of the development process rather than separate activity. Okay?